Hello YouTube hams and electronics tinkerers. N3SDO here with you. In this video I will be exploring and repairing a PM260A electroplating power supply. This unit was acquired from a local auction house in damaged condition. Initially it was observed that the variable voltage knob had been broken off, but in digging deeper, turns out this unit had multiple mechanical and electrical issues, including some bad mechanical assembly and unsafe factory wiring. The device made a very loud clunk when moved, and its weight shifted internally, sounding like a loose transformer moving around inside the case like a wrecking ball. I suspect it was dropped during transit. My plan was to see how bad it was, and if the guts were totally trashed. It was a nice-sized metal box with volt and amp meters that might make a nifty case for a ham radio amplifier. I noticed a couple of misspellings on the front panel silkscreen, along with some wording that, well, makes me scratch my head trying to figure out the meaning of an intercourse fuse. After opening the case, it was discovered that it has not one but two transformers inside, a variac, and a high-current toroidal step-down isolation transformer. The variac was not properly attached to the case, and was moving around, and had a bent rotary shaft. The toroidal transformer is secured by a single large bolt, and it was very loose, allowing this transformer to move around also. The variac was extracted and disassembled to assess the damage. The center-mounted rotary contact shaft was badly bent, also affecting the alignment and function of the rotary wiper variable voltage contact. There was also a metal shaft extender which added length and leverage to the rotary shaft and contributed to bending the variac shaft. It still has the brass insert on it that should be inside the plastic adjustment knob. You can see how off-center it is from this angle. This will require a bit of tender, loving brute force to straighten it. A broken wire was also discovered on one of the variable transformer windings. This will have to be repaired and glued down. A piece of bare copper wire was used to patch the winding along with some adhesive to hold the repaired wire stationary. I applied a dab of adhesive to this connection to prevent it from failing like the other one. The connections are repaired, the shaft straightened, the wiper reinstalled, and the variac is ready to reassemble. Now we take a look at the root cause of the original failure. The manufacturer used fine pitch machine screws to mount the variac using drilled holes into the sheet metal case of the variac, and these thin fine threads did not provide enough holding force for the weight on this variac, and stripped the screws out of the sheet metal. I used some deeper thread sheet metal screws for more strength. Now to address the electrical safety issues. Let me state for the record, this is one of the sketchiest electrical items I have ever worked on. First off, the factory cut off the green ground wire on the AC line cord on the inside of the chassis. I have attached and heat shrinked a new ground wire onto the line cord and attached it to the grounding lug on the variac. So we now have a safety ground in the chassis. Here we see the 6 amp fuse in a screw-together fuse holder that has been spliced into the variac by the factory. However, this fuse is incorrectly wired in the output side of the variac, not the AC power input side. Here we see the electrical input and output connections to the variac. If one of these screws comes off, it could release an electrically hot wire to float free inside the chassis, potentially shorting out and becoming a shock or fire hazard. Here we see the wiring for the front panel fuse and AC power switch. What may not be obvious is that the power switch and the so-called intercourse fuse are connected to different wires in the AC line cord. The hot side of the cord is wired to the switch, where the fuse is connected to the neutral side of the line cord, not the hot wire. This is very wrong. The hot wire was rewired, connected first to the fuse, then to the power switch, with the output of the switch then going to the variac. The neutral wire was then rewired to have neither a switch nor fuse in its connection to the variac. While I was in the area, I tightened the nut on the toroidal transformer and applied a dab of thread locker to keep it in place. I needed to remove the bridge rectifier and heatsink to extract the damaged variac. The crimp-on wire connections for the bridge rectifier were soldered in place. This makes for a very reliable connection, as it won't oxidize over time and then overheat. Upon taking the screw out, I discover they are two heatsinks, and there is not a trace of silicone or heatsink grease on either the heatsinks nor the bridge rectifier. However, bridge rectifiers get hot and need a squirt of heatsink grease, along with some between the two heatsinks. In summary, with the damaged variac repaired, the unsafe wiring corrected and some heatsink grease, it can deliver DC power into a load, and that the voltage and current readings are close enough. Happily, this unit will not output the 230 volts the front panel silkscreen says. With the voltage cranked as far as it will go, it measures a safer 23 volts.